Welcome to Chapter 5, or I guess you can ignore the chapters, but welcome to the control statements, or welcome to control statements part 1 of C Sharp. There will be a part 2. This one is a very long chapter, and I would assume that it's a doozy just like the last one. However, I would like to point out that it's not as difficult as one might believe. It's just the concepts might not be readily understandable in the beginning. I assure you that it will come to you very quickly over time. I assure you. When I first learned this, it wasn't necessarily as intuitive as I would have liked it to be. But I had good professors, so let's keep going. So what are we going to learn in these parts? So part 1 is chapter 5, part 2 is chapter 6. What we're going to learn is basic problem-solving techniques, understanding how to solve problems, business problems as well as technical problems. We are going to develop algorithms through the process of top-down or stepwise refinement. We're going to learn and use if-else statements to choose actions that we want and actions that we don't, or to differentiate between actions. We're going to use while statements to execute statements repeatedly. We're going to use counter-controlled repetition, sentinel-controlled repetition. Counter-controlled is like a for each or a for. Sentinel-controlled is like a while clause where it operates until a sentinel is reached. Or is it the other way around? I think I had it right the first time. And then use increment, decrement, and compound assignment operators. If you took my JavaScript class, this is not foreign to you. Increment, plus plus, decrement, minus minus, and then compound assignment, plus equals. Now obviously, what that actually means we'll get into deeper, we'll go deeper into it. But if I switch over really fast, just to give you a quick overview of what it is, just in case you're just watching the beginning because you want to remember. Plus plus just means I want to increment a specific integer by 1. So technically speaking, if I had I equals var I equals 1, or I guess I can say int equals 1, and it won't do that. And then I said I wanted to increment it by 1, I would say I plus plus. And what that actually means, what I plus plus actually means is I equals I plus 1. But it's shorthand, right? I don't want to have to type I equals I plus 1 every time. I can just say I plus plus. If I wanted to say I equals I minus 1, I would say I minus minus. And that's how that works. So and then compound assignment means that I want to add the integer, or I want to add the variable to something else. So how I would use compound assignment, and I guess I can leave these up so you understand what they are. So increment is I plus plus. Oops. Decrement is I minus minus. And then compound assignment is the following. That's compound assignment. So what does that mean? Well, compound assignment means the following. It means I equals I plus whatever's on the right side of that assignment operator. So in this case, 1. But in the case of this, however, I would probably want to do something like this. So I plus equals 3 is a compound assignment. That means I equals I plus 3. Now, these are just shorthand, but you're going to see them a lot when you develop with other developers because shorthand is easier to read, easier to use. It's just faster, it's cleaner code, whatever the case may be. So once again, for the purposes of what increment, decrement, and compound assignment mean, I plus plus means I equals I plus 1. Decrement, I minus minus, means I equals I minus 1. Decrement and increment are always by 1. If you want to do more than 1, you have to do a compound assignment. And of course, you can do a compound assignment with minus, you can do a compound assignment with multiplication, and you can do compound assignment with division. Now, of course, I would assume that is nope, it'll work. And it literally means the same thing. I equals I plus 3, I equals I minus 3, I equals I multiplied by 3 or times 3, I equals I divided by 3. That's what compound assignment does. And it's just shorthand. It makes it easier for you to write your code. All right, let's switch back over. And these are all the, this is the outline, but we're just going to power through it. There's a lot of slides, so I'm going to take my time on certain things, but on other things, I'm going to try to be as succinct as possible. So, what are algorithms? Let's talk about what algorithms do. So, or what they're used for. Computers solve problems by executing a series of actions in a specific order. An algorithm is a procedure for solving a problem in terms of the actions to be executed and the order in which these actions are executed. So it's not necessarily just I need to execute these actions, but it's also a specific order in which those actions need to be executed. Or need to be, executed is the operative word there, so. Consider the rise and shine algorithm followed by one junior executive for getting out of bed and going to work. So, the rise and shine algorithm basically goes through the motions of what it takes to get from your bed to work. So, the first step, get out of bed. Second step, take off your PJs. In certain situations, there are individuals who sleep in their undies or with nothing on at all, so that step can be omitted, but we're going to assume that you had something on when you were in the bed. So, second step, take off your pajamas. Third step, take a shower. Very important step, by the way. A lot of people miss this step. I would like to reiterate that step one more time. Step 3, wash yourself. Step 4, now I know between get in the shower or take a shower and get dressed, there's probably a step missing, like, brush your teeth. So I guess I can replace take a shower with commence hygiene, right? Brush your teeth, shave if you must, for men and women in certain situations. Obviously take a shower, clean your ears, brush your hair, put on makeup, both for men and women, for those who need it or want it. So 3 is pretty much hygiene. 4, get dressed. I would assume that everyone puts on something to cover themselves to go to work. So in this case, it's a junior executive, so that assumption is not only valid, it's probably mandatory to wear clothes to work. 5, eat some breakfast. This is also a step that a lot of us miss, right? So we get up and we just leave. We grab a cup of coffee or whatever, and that's breakfast. And in certain situations, that might not be the most optimal breakfast. But eat breakfast is part of the rise and shine algorithm. And number 6, carpool to work or drive. So 1, get out of bed. 2, take off your clothes. 3, get in the shower. 4, get dressed. 5, eat something. 6, get to work through some transportation means. That is the rise and shine algorithm in a nutshell. So, suppose that the same steps are performed in a different order. All right, so remember what an algorithm is supposed to do. It's supposed to take into account the actions that need to be executed, and it needs to take into account the order in which the actions must be executed. So we're going to take the rise and shine algorithm and let's change it around a bit to see if it actually works. So the order we have right now is get out of bed, take off your PJs, get dressed, take a shower, eat breakfast, carpool to work. Now, in this case, there's a problem. You already put on your clothes and then you took a shower. There are no assumptions here. So let's not assume that, I put on my clothes and I took off my clothes. No, we're actually, based on what you see here, these steps in the algorithm are the steps that we're taking, right? So get out of bed is number 1. Take off PJs is number 2. Get dressed is number 3. Take a shower is number 4. One of these things don't look like the other. So in this case, the junior executive shows up to work soaking wet. The order in which statements execute is called program control. Now, you can cause a lot of issues, and we take that back to programming. You can cause a lot of issues in your development if you don't take into consideration the order in which things are supposed to be executed. Now, when I say supposed to be executed, I'm not saying that there's this unsung rule that everything is supposed to be written in a certain manner. That's not C#. You're talking about SQL. And SQL's got a lot of rules that you must abide by. So does development in C# and JavaScript and all these other languages, but for the most part, program control is to ensure that you don't get logic errors. Now, there are times you can get syntax errors with program control. What is the difference? A syntax error is an error that happens when you try to compile your code, or you try to, in the case of JavaScript, run it. It's an error that says you can't do this, or this variable has no value, or you missed a semicolon. That's a syntax error, right? A logic error might not throw an error, but you know it's an error because it's not returning the correct value of a specific thing. So for instance, let's say you have a Fahrenheit to Celsius algorithm and you need that, or equation, and you need the Fahrenheit to be converted into Celsius. Well, or here's a better example because I know the values. You need miles converted into kilometers. Each mile converts into 1.6 kilometers. You would know that there's an error in your code if you put down 1 mile into the calculator, but you only got 0.6 kilometers. In that situation, you're getting a logic error. Now, will it throw? Will the computer automatically, without you telling it to throw an error? Probably not. And the reason why is because everything ran the way it was supposed to. The computer knows, the program knows that if there was a syntax error in your code, I'd throw it. I.e., I wrote it wrong, i.e., it's not running correctly when I compile it or I run it at runtime. But everything ran. No, that's a logic error. When everything runs, but the values are still not correct, that's a logic error. And those errors are harder to catch. Program control also helps to mitigate logic errors too. So, what's pseudocode? In a nutshell, pseudocode is code that's written out, but it's not the actual code lines. Pseudocode is the way that code is written, or the way that we want it to be written. You've already seen pseudocode, by the way. In your assignments, it doesn't necessarily tell you verbatim what to write, but it tells you what should be there. That's what pseudocode is. It's really not a programming language. It just helps you brainstorm what the app is supposed to look like before you attempt to write it. A carefully prepared pseudocode app can easily be converted to a corresponding C# app. Now, I will say that in the real world, that doesn't necessarily always hold true. Now, when I say hold true, I mean the creation of pseudocode. Pseudocode is not always used. Sometimes you're coding so quickly or you already know what you really need to do that the pseudocode really isn't written. That's not a bad thing. There's not some industry standard that says you must write pseudocode first. But it would help a lot if it was already written by a BA or something along those lines to give you a better idea of what you're trying to do. In most instances, though, you're already really going to know what you need to do once you see the requirements. So, if you get requirements. Normally, statements execute one after the other in sequential execution. In higher level languages like C# and Java, this is true. C# statements enable you to specify the next statement to execute. This is called transfer of control. So you have program control, which is the flow of your program and how it executes. Then you have transfer of control between statements. So let's flip over for a second back to what I had here, and I'm going to erase this because I feel like we've talked about that enough. So in this case, you have gradebook 1. This is from the last session we did, by the way. Equals new gradebook, right? And we're not going to go into great detail about what this is doing. We're just talking about transfer of control. So in this case, what this does is it executes something in the gradebook class. Once it's finished doing what it needs to do, it transfers the control of the execution to the next line. And then the next line does what it's supposed to do. Think of it like individuals standing in a line, right? At Chick-fil-A or at McDonald's, or a line of cars at Chick-fil-A or McDonald's. The first car puts in its order, and then McDonald's does something and gives it to that person. And then the next person then gets a transfer of control because they are able to drive up to the microphone and speak to the restaurateur and get their things ordered and whatnot. And it's kind of the same idea here. This line is waiting, so gradebook 2, this line right here, is waiting for the ability to request what it needs. And then it passes on to the next line, which is then waiting for the line before it to do what it needs to do, complete its task, and then so that it can run. Structured apps are clearer, easier to debug and modify, and more likely to be bug-free. That's all. I guess that goes back to that beauty's in the eye of the beholder thing. I've been doing it too long. Bugs will be there. There's never. I know that scientifically you can't use the word never. Never and always are always false. They're always false. But I will tell you, anecdotally speaking, I have never seen a code base or API or development paradigm written that had 0 bugs. In the instance of it, had 0 bugs. I mean, when you write it the first time, it's probably in draft form, and then you go from there to a different form and yada, yada, yada. So, an activity diagram models the workflow of a software system. Activity diagrams, or UML, if you're really into the old school way of doing things, are composed of symbols such as action state symbols, diamonds, small circles, and notes. And this goes into understanding how a business analyst or a systems analyst or a project manager might give you a user story. What's a user story? A user story is, this is the process that the user does right now. This is the process we need the user to do in the future. And it is up to us as developers to achieve the technological advancement of the future. Excuse me. Wow, I had some air stuck in my chest, I guess. That's not a bad thing. I have lungs. But I'm having a hard time getting out. Transition arrows represent the flow of the activity. The solid circle represents the activity's initial state. So this is the way it began. The solid circle surrounded by a hollow circle represents the final state. So let me click over, and here we go. This is actually UML. Unified Modeling Language, I think is what it's actually called. So this circle starts the process. This is how we know it started. Add grade to total is the pseudocode. This side, the corresponding C# statement, actually, I would like to write. Yes. So this is the pseudocode, and this is the actual code. Now, obviously, this would not be in your UML diagrams, but this will, and so will this. Add I to counter. Well, we already know we need to do that, so we can write that in. Sometimes pseudocode is belittling when you're a developer because you kind of already know what you need to do. And sometimes, I guess belittling is not the right word. Sometimes it puts you in a box and you really can't develop outside of the box. Sometimes you need to develop outside of the box to solve other issues. So, I don't know. I like pseudocode, but I like it as a guide, not necessarily as what you should be doing. Think of pseudocode like Google Maps. Sometimes Google Maps doesn't really know the most efficient position or the most efficient way to get somewhere. It might not see a road, or that road might not have been mapped to Google Maps, but you know that road exists because you live there and you've seen it multiple times. So you'll take that road because you know it's more efficient. Now, obviously, sometimes Google Maps is correct in stating that you should have went down the place that it told us to go down, but it doesn't complain. It goes rerouting, and then it says, you will now reach your destination in 3 hours instead of 5 minutes because there's probably an accident down that way or whatever. But what pseudocode does is it gives you an idea of what it should look like code-wise. I've never seen pseudocode as the de facto way of doing something. Sometimes individuals really don't know that certain things can't be done. Single entry, single exit control statements make it easy to build apps. Control statements are attached to one another by connecting the exit point of one to the entry point of the next. This procedure is called control statement stacking. Once again, we're not really talking about development right now, so I'm going to speed up just a little bit because this is more talking about the way it's written outside of the code world. Control statement nesting allows a control statement to appear inside another control statement. Whenever you see the word nesting, just understand that it means you're inside, basically inside something, or inside a like object, right? So another way of making this nesting idea more prevalent outside of the scope of to make a more modern definition of nesting would be multidimensional. So what we call multidimensional back once upon a time it was called nesting, like nested if statements. You don't say nested arrays, you say multidimensional arrays. So I mean it's all in how you look at it. But either way, control statement nesting allows a control statement to appear inside another control statement. If grade is greater than or equal to 60, display passed. The preceding pseudocode if statement may be written in C# as this. So this is the actual code here. This is the pseudocode there. Remember, pseudocode cannot be ran in C# or any other language for that matter. It's not an actual language. It's just a written way for us to understand what needs to occur. And then we can actually convert that into something that the computer would understand. In this case, an actual if statement. The C# code corresponds closely to the pseudocode, and that's the idea. The pseudocode is not supposed to necessarily be the written code. It's just supposed to give you a guidepost on what to do. In most situations, though, you wouldn't... Well, yeah, actually, this makes a lot of sense, because I've actually gotten something like this in a project that I'm doing right now, where, for instance, customer is spending less than $500, pull record. So in this case, yeah, it's not out of the ordinary. It wouldn't be this simple. You would need to do a lot more than just, well, it may be that simple, actually. Let me not say that. Figure 5.2 illustrates the single selection if statement. The diamond, or the decision symbol, indicates that a decision is to be made. The workflow will continue along a path determined by one of the symbol's two associated guard conditions. So, this is the start. That is your if statement. Normally when you see open diamonds like that, that's basically a decision structure. This is the end, right? So if the grade is greater than or equal to 60, display passed, and then dispose of the program. If the grade is less than 60, just go straight to dispose. Which, by the way, I would state that this should have an alternative decision structure. Instead of just going straight to close, it should say failed. You failed. How would this user know if they failed or not? If they received no, if they didn't receive a printout of some sort. The if-else double selection statement allows you to specify an action to perform when the condition is true and a different action when the condition is false. So understand this. What we call here, this condition is a Boolean expression. What's a Boolean expression? A Boolean expression is an expression that can either be 1 or 0. It can only be one or the other. Boolean expressions only contain two specific outcomes. If you go deeper into computer science, you will understand that that's the basis of all computer science. A bit can either be 0 or 1. It cannot be anything else. And that's what a Boolean value is. Literally. Just a representation of 0 or 1. I won't get too deep into discrete mathematics, but in the world of computer science, discrete mathematics assigns 1 or 0 as a value to a specific item, whether that's a transistor, a bit, a memory location, or whatever. In this case, if grade is greater than or equal to 60, I want you to say it's passed. So if this Boolean value is a 1 or true, then I want you to do this. However, if this Boolean expression turns out to be false or 0, I want you to run the else. That's what this is basically stating. So, indent both body statements of an if and else. That happens automatically in Visual Studio, so no worries there. But if it doesn't, please indent it. Not because it's not going to run. Indent it because other individuals may be reading your code, i.e. me. It makes it easier to read. I can see where the errors might exist. So, if there are several levels of indentation, each level should be indented the same additional amount of space. What that essentially means is that if you have an if statement and you have things in that if statement, as long as nothing is inside anything else, then put them all in the same indentation. However, if you have an if statement that's got another if statement, or let's say it has a for statement in it, right? Then indent it for the for statement. What that does is it allows other developers and yourself to know that these statements are in the for statement and all of these statements are in the if statement. It's just easily readable. If you do not do that, you'll run into a situation where other individuals are asking you a lot of questions because they really don't understand what they're looking at. So we're going to look at 5.3 to see the flow of control in an if-else statement. And this is what I actually just said. So we have the start. It goes down to a decision structure. This means I'm making a decision, or the program needs to make a decision. And then if it's less than or equal, if it's greater than or equal to 60, passed, and then in the program. However, if it's less than 60, I want you to display the failed, and I want you to end the program after the failed string is displayed. The conditional operator question mark and colon can be used in place of an if-else statement. And we talked about this in JavaScript. This is called a ternary operator. And what a ternary operator is basically shorthand for an if statement. It pretty much asks the conditional statement or the Boolean expression, is the grade less than, or if the grade is greater than or equal to 60, then, that's what that means, then display passed, else display failed. Now here's the problem with ternary statements or ternary operators. I guess it's not really a problem. With a ternary expression or operator, you have to display both the if, which is this, the true, and the false. If you don't, it won't run. So you have to have both the true and the false expression for the ternary operator to operate, or it won't. So the first operand is a Boolean expression. We talked about that, blah, blah, blah. The second one expresses the true, and the third one expresses the false. We talked about that. So here's a Boolean expression. That's the true expression, and that's the false expression. Or this is what fires when this is true. This over here is what fires when this is false. And you can place it straight in the console.write line. It will run. As a matter of fact, just to show you, I feel like getting into the code. So let's do it. I have nothing in this main, and let's write it. Console.writeLine. And we need grade, right? So let's get grade. Stop it. Int grade equals to int. What? Why am I not getting to int 32? We'll just do that anyway, and then hopefully it does what it's supposed to do. Console.readline. So console.readline always returns a string, and I don't want it to return a string. I want it to be converted to an integer. So in this case, I'm going to ask for it to, but I don't want to generate a method. Interesting. Why isn't it working? It's not at the end. I know it's in the beginning. Oh, I'm doing that wrong, maybe? No. Give me 1 second. I thought it would give me the new window. Oh, it is on the back, I think. Maybe I did that wrong. I did it wrong. There we go. Ah, it didn't work. Where is it? Hold on. Just to show you what I'm looking at the, I know it exists. I just need to look at to see how to use it. And as I said before, this is not plagiarism, especially when there's a data dictionary developed for the developer network. So if you ever want to find out what something actually does, let's say you know that it can be done, but you don't know the actual syntax. This is the syntax for it. And then just look it up. Got it. Boom. There it is. Boom. All right, and then I can just write that ternary operator in here to show you that it would do what it's supposed to do. So greater than or equal to 60. The string should be passed, and the string should be failed. And then I want it to stop until I press the enter key. Wonderful. All right, so let's run it. Well, no, let's talk about what it's doing. So I initialized an integer called grade. I'm asking the user to give me, I should probably tell the user to give me a value. Console.read, please enter your grade. Okay. So console.write writes a string, please enter your grade. And then I'm initializing an integer grade, or integer grade variable. And then what I'm doing is I'm asking the user to give me their grade, and I'm converting it to a value of, or I'm converting it to the data type integer. If I didn't do this, it wouldn't work. So if I got rid of, let's say I got rid of that, I automatically got an error. And it's going to tell me that it cannot implicitly convert string to int. I don't know if you can see that. If I scroll down to it, I can scroll to it. Cannot implicitly convert string to int. The reason why, console.readline always gives a string data type back to your program. So what I need to do is convert this first. So I convert it to int, and I should be good there. And then what I'm doing is I'm telling the console.readline that if the variable grade is greater than or equal to 60, I want you to print pass, otherwise print failed. So let's see if it worked. My computer's been running very slow lately. I'm not too happy about that. All right, here we go. Please enter your grade. So the first line ran. It compiled without errors, so I'm guessing it's doing what it's supposed to do. Let's put in 59. See what we get. Failed. So it worked. Well, I knew it was going to work. But ternary operators are amazing. They make your code that much more readable, and it makes it's easier for individuals to kind of see what's going on. If I wrote an if statement in there, it would take up more lines. The more lines you have running in your class, the slower it becomes. I mean, by a factor, of course, but it's still slower, blah, blah, blah. So, let's go. When a conditional expression is inside a larger expression, it's good practice to parenthesize the conditional expression for clarity. Adding parentheses may also prevent operator precedence problems that could cause syntax errors. And we'll go over that later as well. So, here's a nested if statement. Give me a second. Tea's getting cold. An app can test multiple cases with nested if statements. So here's a nested if. If grade is greater than or equal to, else, if, else, if, else, if, else, as the goes on and on and on and on and on. So in this case, we have an if statement with else statements that have if statements within them. There's a better way. But here's what it would look like if you wrote it in C#. If, else, and then another if statement with an else, and then another if statement with an else, and another if statement with an else. I'm not going over what's inside it because it's irrelevant, to be honest. Just I want you to see that you can take an if-else statement and put another if-else statement inside it. I'm also telling you there's a better way, but we'll go over that too. Most C# programmers prefer else if. So, in the last example, it was just if-else, right? In this example, it's if, else if. Now, what that does, the difference between else and else if. Else does not require a Boolean expression or a conditional expression to run. It literally means everything else. So when you get down to this else at the bottom, that literally means everything else. Everything else, I want you to just do this. Even if it's null, even if it's undefined, I do not care. Everything else, do the last expression, do the last statement. Else if will always ask for a condition. It needs the condition to satisfy the if statement. So if grade is greater than or equal to 90, I want you to print an A. Else if grade is greater than or equal to 80, print a B, and so on and so forth. This is the way we normally do if statements if we have other conditions that need to be met. So a dangling else problem. The C# compiler always associates an else with the immediately preceding if, unless told to do otherwise by the placement of braces. This behavior can lead to what is referred to as the dangling else problem. Now, what does that mean? Well, that means this. If x is greater than 5, if y is greater than 5, I want you to print that x and y are greater than 5. Now, how it really interprets it is like this. If x is greater than 5, y is greater than 5, then x and y are greater than 5. Else. Now, obviously, it looks like it might be the same, but they're not. And we're going to see why in a second. To force the nested if-else statement to execute as it was intended, you want to write the braces. Check first that the x is greater than 5, then check to see that the y is greater than 5. If you do not do that, you're going to get a syntax error, and you might even get a logic error. A set of statements contained within a pair of braces is called a block. So this is a block of code. I know I dare say that majority of us have heard that before. So if grade is greater than 60, write past. Else. And then in this block, the else statement will run. You failed. You're going to take the course again. Without the braces, the last statement would execute regardless of whether the grade was less than 60. The else would fire because it doesn't know that the else is a part of the if. And we've talked about logic errors, correct? Logic errors are not necessarily captured unless you're running a try-catch, and we haven't talked about that, so I'm not going to go into great detail about what that is. But what a try-catch does is it allows you, as a developer, to set certain parameters or exceptions, or what we call it, when logic errors rear their ugly heads. A logic error has its effect at execution time. A fatal logic error causes an app to fail and terminate prematurely. I know you've seen situations where your app just goes boop and it dies. A non-fatal logic error allows an app to continue executing even though you're getting the wrong value. We talked about Fahrenheit, Celsius calculators, and we talked about miles to kilometers calculator. Well, there's nothing wrong. It's not a fatal logic error. The program's not going to die, but the value that you're getting back is not correct. But the program doesn't know that. The program actually doesn't care. All it cares about is to do exactly what you asked it to do. So to it, there are no errors. A non-fatal logic error, these are the hardest to find and even harder to fix. Some programmers always use braces in an if-else statement. I will tell you, it is not some programmers. It is correct syntax to always use braces for everything. You will never, and once again I said never is never true, right? I'm honest. You will never see my code in a state of no braces for blocks. That is the most integral thing you could ever use in your code. Placing a semicolon after the condition if in an if or else statement leads to a logic or single selection if statement error, and a syntax error in double selection if else statements. Don't use semicolons after if statements. Use braces, no semicolons. It will throw an error. The if statement is not a block. It's a condition. Or it's not a statement, actually. A repetition statement allows you to specify that an app should repeat an action. Now, we don't call those repetition statements. What we call those are loops. And there's two types of loops, sentinel loops and iterative loops. But we'll continue. As an example of C# while repetition statement, consider a code segment designed to find the first power of 3 larger than 100. Okay? So, power of 3 larger than 100. Remember we spoke about assignment operators or compound assignment operators? You see a problem here? Yeah, I do. Product equals 3 times product. You don't have to write it that way. You can say product times equals 3. Boom. Compound assignment. But in this case, int product equals 3. And while the variable product is less than or equal to 100, I want you to increment or execute this equation. Not providing in the body of a while statement an action that eventually causes the condition in the while to become false normally results in a logic error called an infinite loop. Now, I know that most, if not all of you, have heard about what infinite loops are and what they can do. They're pretty awful. So, and we're going to look at how a while statement, what it looks like in the UML. And here we go. Start if. So this if statement is looking at, this if statement goes down, or this, if the product is less than or equal to 100, triple the value of the product value and come back here and do it all over again until this is true. So consider the following problem statement. A class of 10 students took quiz. The grades, integers with a range of 0 to 100 for this quiz are available to you. Determine the class average on the quiz. The algorithm must input each grade, keep track of the total of all grades input, perform the averaging calculation, and display the result. Interesting. Let's see what they tell us to do. Or actually, no. I want to see what they tell us to do before I develop it. So first, pseudocode algorithm with controlled repetition. We use a counter-controlled repetition to input the grades one at a time. A variable called counter controls the number of times a set of statements will execute. Counter-controlled repetition is often called definite repetition because the number of repetitions is known before the loop begins executing. Experience has shown that the most difficult part of solving a problem on a computer is developing the algorithm for the solution. Once a correct algorithm has been specified, the process of producing a working C# app from it is normally straightforward. Normally is the operative word there. I would posit very strongly that this is hearsay. Just ignore it. That's not necessarily true. I'm actually doing a project right now where they did write pseudocode only to realize that the business process did not meet the requirements of the pseudocode. So this is not necessarily true. It's not as straightforward as you think. So we'll talk. Oh, well, would you look at that? Gradebook, eh? So let's implement the grade algorithm in the gradebook. And here we go. That's the pseudocode. Set the total to 0. Set the grade counter to 1. While the grade counter is less than or equal to 10, prompt the user to enter the next grade, input the next grade, add the grade into the total, add 1 to the grade counter, set the class average to the total dividend by 10, display the class average. Let's go ahead and do that. We'll get rid of this because I don't need it. And I will keep all my other code because I have a sneaking suspicion I am going to need it. So, set the total to 0. And that's the counter? Very well. So, let's do a for statement then, shall we? And we'll have a couple of things. So, first of all, we need a int. I'm not going to assign assessor to it because this is in the main. So, who cares if it's public or not? So, we're going to say int average, or grade average, equals 0, because it said I need to set the total number to 0. Oh, grade total. Set the grade counter to 1. Well, in this case, I'm using a for statement, but I guess we can do that. And we'll say int counter equals 1. And then we can say while the grade counter is less than or equal to 1, so counter less than or equal to 1, or 10, I'm sorry. Prompt the user to enter the next grade. Oh, okay. So we'll say int grade equals convert.int 32. Because remember earlier, when I do the console.readline, I need it to be an integer when I bring it back so I can do some algorithms on it. I can do some mathematical computation on it. If I try to do a mathematical computation on the string that the console.readline will give me back, it'll tell me that there's an error, or it'll do something even worse. It will concatenate that integer to a string. Remember in JavaScript, for those of you who took JavaScript, that if you added an integer to a string, that it concatenated them together to make a string? Let's just not even go down that road. Let's let's assign a data type to it when I receive the value. So I'm assigning the data type integer to whatever the user gives me. Oops. And then I'm going to go to the next line. Input the next grade. To where, pray tell? Add the grade into the total. All right, so they've already gave me the input. I added it to the integer grade. Now what I want to do is I want to add the grade to the total grade. So I have the grade total out there already. Let's use it. Grade total. What did I just do there? What does that say? So it told me, and I'll flip back over so you can see if you're not following along with the PowerPoint, it told me to set the total to 0. Check, did that. I set grade total to 0. It said set a counter to 1. Check, did that. Then it said while grade counter is less than or equal to 10, right? So I did that. I made a while loop, and I said while counter is less than or equal to 10. Check. Prompt the user to enter the grade. Check. Input the next grade. I actually I put these in the same line. So I actually didn't do what it asked me to do. Now that I think about it, I need to prompt the user. I also need to tell the user to enter a grade. Silly, silly, silly. Please enter your grade. There. And then I asked for the input and they gave it to me. Console.readline. Check. Add the grade to the total. I did that. Grade total plus equals grade is grade total equals grade total plus grade. Check. Add 1 to the grade counter. Okay, let's do that. Counter plus plus. And just for your reference, I'm going to add comments. Okay, so for those of you who have had your assignments graded and you've had 15 points reduced from your grade, I will tell you the reason why. I am a stickler for comments. I don't really mind it not being all over your code, but you must add comments. So what I'm going to do is I'm just going to take these pseudocode comments and I'm going to add them. As a matter of fact, let's do it that way. I don't like doing it this way, but it means that I'm not going to have a lot of white space, which is something I don't want. Now, please don't write this much. As a matter of fact, you see this while statement, all I really want is to understand what it's doing. So you can say, for the whole block, remember the braces mean a block. So just explain what the block of code is doing. If it's a long block of code, then explain a little better inside the block of code. But here, I'm going to write this exactly the way that I would write it. So while counter is less than, or, well, I don't have to do that because I understand what that means. Ask for grade. And then so to me that's one whole thing. And then I would say add grade to grade total and increment counter by 1. Boom. There we go. That's really how I want. This is how let me erase this just so it's not kind of confusing everyone. This is exactly how I want you to write your comments. Block it out. Don't do it per line. That's asinine. I mean, don't insult the person reading your code, but at the same time, let us know what's going on so that we're not necessarily kind of looking out like out the side of our head like, what is that doing? Okay, so it looks like my while statement's done because once you start incrementing or decrementing in your while, you're pretty much where you need to be. So now set the class average to the total divided by 10. So grade total, I need int grade average equals 0. Class. And then I want to grade average. And this is a simple algorithm. We're not going to make it too complicated. Equals grade divided by, not grade total, grade. No, I do need grade total. Grade total divided by counter. So what is that going to do? Well, the grade total is going to be somewhere between 0 and 1,000 because I have 10 grades. The counter is the amount of grades that I have. So if I want to get the average, I divide the total grade number by the amount of grades that I have. And then I want to display it. So console.writeLine is, and then I'm going to say grade average. Done. Oh, no, I'm not done. I am not complete. I need to make sure that the code doesn't just go away. And there we go. So let's go over what we just did. All we did was we took the pseudocode that you see here and we made it into code. Fancy that, right? Here, let me try to move that over so you can kind of see it side by side. So set the total to 0. Check. Set the grade counter to 1. Check. Or here's integer equals 1. I also need to create an average. Remember when it said that it makes it easier for you to write bug-free code, but it didn't tell me that I needed a grade average integer. I realized that after the fact. I was like, oh, well, I need something to hold the grade average. So now, obviously, I didn't have to do that. I could have just used grade total, but I don't know. I like making it a little cleaner. So I made another integer called grade average. Now, I do not like when people call me restricted. So I have a while statement here. While counter is less than or equal to 10. While grade counter is less than or equal to 10, prompt the user to enter the next grade. Did that. Console.write. Input the next grade. Did that. Add the grade into the total. Did that. Add 1 to the grade counter. Did that. Set the class average to the total divided by 10. Did that. And then I'm going to write it out. Let's see if it works. Now I'm going to have to write in 10 grades, but here, bear with me. So we'll say 75, 82, 99, 56 or 54. Apparently my fingers wanted to put 54. 79, 67, well, 85, 89, 92, 30. The grade average is 68. So it worked. Now, obviously, I don't know if this is right, so let's do our own calculations, shall we? Now, I wonder why that is. It only took 9. Actually, yeah, it only took 9 numbers because we started at 1 instead of starting at 0. Actually, that's incorrect. If I'm not mistaken, yeah. Interesting. How did I get a logic error? That doesn't seem right. What was the counter? Actually, I can check to see what the counter was. Where is it? Counter. There. Oh, I can't. Why not? I should be able to... I should be able to see what's... Oh, I didn't breakpoint it. Alright, well, forget it. But it did work. And it did what it was supposed to do. But I'm sure this is not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it was 10. Well then, maybe I'm doing this wrong. But that's interesting. So why did it give me 68? Logic error. I will figure that out later. But that is the average it gave me, so apparently that's correct. Or maybe I was typing the numbers wrong. I don't know. Alright, cool. Let's keep going. And here we go. So they actually did it the right way. What they did was they used object orientation to write this. So let's change it up a bit. Right now, this is what we have in our gradebook class. This is what we have written in our main. We just need to add this to our gradebook class. Now, how do I do that? Well, I already wrote it, so I can just go whoop, go back to gradebook, and let's create another class. Let's create a class called public void, and obviously I'm typing from the slideshow, but determine class average. That's absolutely not what I wanted to do. Now let's add our code there. And I am sure they're doing exactly what we did. They are. They also have the total. Huh. Why would they do it by 10 when they already have the number 10 in the counter? That makes no sense. Oh, wait a second. Maybe it did 11. What? No good. Let's do that. Nope. That. Now I understand why it was 68. It was a logic error. And if I'm not mistaken, that is how they did it. We've already written the code. We just put it inside of our own method now. Separate declarations from other statements and methods with a blank line for readability, as you see me do. As you see that I do. So, the method determine class average. A variable is definitely assigned when it's guaranteed to be assigned a value before its variable is used. That was confusing. Hold on. A variable is definitely assigned when it's guaranteed to be assigned a value. Oh, okay. Got it. Makes sense. It's just telling you that it's been assigned, but it hasn't been used. Using a value of a local variable before it's definitely assigned results in a compilation error. All local variables must be definitely assigned before their values are used in expressions. Meaning that you have to say, and this is not necessarily true, but int grade total has to equal something before it can be used. Let's test that theory. Yep. Okay, so I didn't know that. Wow. Okay. In order for grade total to be used, it has to have a value. In this case, it's null, so when I try to add something to it, it says nothing can be added to null. Use of an unassigned local variable, so I have to definitely assign it a value, and boom, it works. Okay? Wait, I did know that. I just didn't know it was called being definitely assigned. Initialize each counter in total, either in its declaration or in an assignment statement. Total are normally initialized to 0 or null. Counters are normally initialized to 0 or 1, normally 0, depending on how they're used. So, gradebook test creates an object of gradebook. So let's go back to our program, and let's go back to the way that it was. So I'm just going to Control Z all the way back. Alright, we don't want that. And we've already created the gradebook object, and we will yeah, I don't want that. Okay. Alright. So we will take this back to the way that it was. So in this case, gradebook, because we want the value, we'll just get rid of all this. Yeah. So gradebook is the data type of the class that we created, right? Remember? So the gradebook class is here in gradebook. So now what I'm going to do is I'm going to assign it a variable, my gradebook. Now what I want to do is I want to take this class and I want to build it into this variable. So new gradebook, and then I'm going to give you the name of the class. So the name of our class, 214. Okay, so far so good. Now what I want to do is I want to execute some things on the gradebook. I want to execute some things on the class that I just created. So this is called instantiating a class. Now the variable my gradebook contains all the things that are inside of the gradebook class. So now I can use my gradebook in the main. So in this case, I'll say my gradebook and dot. Now, we created course name, that's a property, remember? We also created determine class average, I just created it. And we created display message. These are the three things that we created. Course name, judging by the wrench, is what? It's a property. It's a property that's accessible outside of the gradebook class. Determine class average is a function, judging by the 3D purple box. And display message is a function. So let's run both of those. Display message. And then my gradebook dot determine class average, which will find average 10 grades. Now, if I ran that, what would happen? Well, I would more than likely get prompted with a message that says, welcome to CIS 214 Object-Oriented Programming with C#. And then I would be asked for grades. Let's see if that is actually what happens. Welcome to Gradebook. Please enter your grade. Now, of course, I could, well, no, I won't do that, but it worked. Now, if I enter the grades, of course, it would go through the motions that we just went through when we developed it. And the reason why is because we placed that function here in the gradebook class. Now I can access it whenever I want to use it. This is one of the main tenets of object orientation. Being able to take a class and use it only for what we intend to use it for. This is the first letter of SOLID. What's SOLID? It's an object-oriented principle acronym. And I'm not going to go too deep into it because it's not, I don't know if we're going to go over it in this class, But the first part of it is single responsibility. And what that means is that every class has a single responsibility. It has a singular function. It does one thing. In this case, the gradebook class maintains the gradebook. So the gradebook class will tell us or give us functions to be able to manipulate grades, to display grades, to show you the course name of that specific grade book. These are all the same functions of the class, the singular responsibility. So, and let's go ahead and just run this real quick. I want to see if we can replicate these numbers. So I'm going to start, and here it is right here. And let's enter our grades. So 88 plus 79 plus 95, 48, 83, 90, 85. I should get, oh, they want that too? Okay, we can do that. Before I finish this, let's flip back over so we get both the average and I want to get the total. So the total number of, I can't change it while it's running, so let's get rid of that. And then let's say console.WriteLine. And then I'll say total of all 10 grades is, and then I can not do that, and then do that. And then I want the, obviously, the first. What did I just do? So I said I want to write to the console this string. Total of all grades is, but what does 0 mean? Well, we spoke about that in the last overview. What the 0 does is it tells the program that I want this next parameter that's here. If I wanted more than one parameter, I can just say, param2. Param2 doesn't exist, but let's just say param2, and then I can say that. And I can keep going on and on and on and on and on, building my string. But I'm not going to do that. I'm just going to do the 0th position. Okay. Let's see if it runs. Try it again. And I'm going to use the same numbers they used to see if I get the same thing they got. So, enter grade, 88, 79, 95, 100, 48, 88. Oh. There we go. 88, 92, 83, 90, and I don't know if I put these numbers in right, and I got it. That's awesome. So it worked. As a matter of fact, what I should do is this. Oh, that's annoying. I can't do anything while it's running. I flip back over and I do that. I should actually get it formatted exactly the way they have it formatted. I'm not going to change this because I like it all on the same page, on the same line. So 88, 79, 95, 100, 48, 88, 92, 83, 90, 85. Boom! Up in the room. It worked. Oh, you didn't even see it, did you? That stinks. I'll write it again. I like it when code works, so that's fine. 88, 99, 79, 95, 100, 48, 88, 92, 83, 90, 85, and there it is. It worked. Wonderbar. So, dividing two integers results in integer division. Any fractional part of the result is lost, truncated, and not rounded. Why is that? That's because integers do not display decimals. So if I try to divide two integers and I'm supposed to get a decimal back, well, integers are whole numbers, so I'm not going to. If I want to get decimal backs, I have to either say decimal as the data type, float, or double. Assuming that integer division rounds rather than truncates can lead to incorrect results. For instance, 7 divided by 4 which yields 1.75 in conventional arithmetic truncates to 1. It doesn't round up or down, rather than rounding to 2. It'll always just truncate it to the whole number. It does not round if you use integers as data types. Consider the following problem. Develop a class averaging app that processes grades for an arbitrary number of students each time it's run. That goes back to what I was trying to do before. I was trying to make counter the number that it divides by rather than a set number 10. Now, of course, in this example, no indication is given of how many grades the user will be entering during the app's execution. So, a sentinel value can be entered to indicate end of data entry. This is called sentinel control repetition. Sentinel control repetition is often called indefinite repetition because the number of repetitions is not known before the loop begins. The sentinel is just a arbiter of when to stop. That's basically it. So basically, you can say readline, right? So console.readline is a while loop. Actually, it's a great example of a while loop or a do while loop with a sentinel controlled repetition. It'll keep going until you press enter. Once enter is pressed, the sentinel has been achieved, and you leave the loop. That's what console.readline actually does. It allows you to input whatever you want until you hit enter. That enter is the sentinel controller, the arbiter. It's what stops the loop from occurring. Choosing a sentinel value that's also a legitimate data value is a logic error. So, if in this case we selected an integer as a sentinel value, then you will more than likely get a logic error. So, we can develop the pseudocode algorithm for top-down stepwise refinement. We approach the class average app with a technique called top-down stepwise refinement. The top conveys the overall function of the app. Determine the class average for the quiz. We divide the top into a series of smaller tasks in the first refinement. So initialize variables, input, sum, and count the quiz grades, calculate and display the class average. Each refinement, as well as the top itself, is a complete specification of the algorithm. Only the level of detail varies. So what happens is I get a high level, right? We need to average all the grades. And then in that high level, we'll break it down into smaller levels that we can actually develop. Many apps can be divided logically into 3 phases. An initialization phase that initializes the variables, a processing phase that inputs data values and adjusts variables, counters, and totals accordingly, and a termination phase that calculates and outputs the final results. So 3 phases to this top-down refinement. It's initialize the variables, input the data, and then terminate and give the value of whatever was asked for. So, proceeding to the second refinement. The second refinement specifies individual variables. So, as you saw it when we developed it the first time, initialize the total to 0, initialize the counter to 0. Now, I never initialize counters to 1, and the reason why is because everything in computer science, everything in IT, everything that you will find in the tech world starts at 0. So, input, sum, and count the quiz grades. This is the second refinement of the preceding pseudocode statement. So, this is being refined down into this. Input, sum, and count the quiz grades. Now I need to walk through how to do that. Remember the rise and shine algorithm of get up, take off your PJs, get in the shower, eat some breakfast, whatever the actual rules were, and how the schedule, not the schedule, but the control flow, the workflow. This is the workflow for the input, the sum, and the quiz grades for both the user and the developer. So prompt the user to enter the first grade. Input the first grade, possibly the sentinel. While the user has not yet entered the sentinel, add this grade into the... So as long as the sentinel has not been achieved, so in this case, like I said for console.readline, as long as the enter key has not been pressed, or whatever the sentinel you choose to be, then do some stuffs. And when the sentinel is achieved, then the while loop ends. Calculate and display the class average. The preceding pseudocode can be refined as follows. If the counter is not equal to 0, set the average to the total divided by the counter and display the average. Else, display no grades were entered. We are careful here to test for the possibility of division by 0. You don't want to divide by 0 because you will always get an undefined. You can't divide by 0. The complete second refinement of the pseudocode for the class average problem is shown in figure 5.8. When performing division by an expression whose value could be 0, explicitly test for this possibility and handle it appropriately in your app. You will get an error message. Error messages are not graceful. So if the user gets an error message saying that you can't divide by 0, they get miffed. The reason why is because errors let the user know the program's not working as intended, whether or not they're the cause or whether it was coded that way. Try to avoid errors as much as you possibly can. So here's the actual class average problem pseudocode algorithm with a sentinel controlled repetition. So as always, I like to try to do it before we see the actual answer, because I don't really know what the answer looks like. This is a 100-slide PowerPoint, so let's see what we can do. So we have the class average. Initialize the total 0, check. Initialize the counter to 0. Not done. Check. While the user has not entered the sentinel. Oh, prompt the user to enter the first grade. Input the first grade. All right. Too easy. So, console.write. Please enter the grade. And then I'm going to capture that. Grade total plus equals convert to int. I can do the typing. We'll say 16 this time. Console.readline. Wonderful. What is that going to do? It is going to, this actually says grade total equals grade total plus whatever that is, which is what the user is going to enter. We're also going to get rid of this because this is not what it's going to do. While the user has not entered the sentinel, so while, oh, I don't know. What would the sentinel be? It's a good question. Because that means I would have to get some type of... Hold on a sec. Count. Once again, I am looking up certain things. So I want the loop to continue until a key is pressed. So read key would let me do that. Found it. So what that's saying is console.readKey means that I'm asking the computer to tell me what key was pressed, right? Now, enter is not a good key because they're going to be pressing enter a lot based on console.readline. So maybe enter is not the right key. Maybe escape's the right key. Okay. And that's that right there. I don't know if escape's going to cancel it though. So let's check that out first. It doesn't. Perfect. So let's do that. So console.readKey dot key is not equal to console key dot escape. All right. So that's what it looks like right now. So I initialized grade total 0, initialized grade average 0, initialized counter to 0, and then please enter the grade. I then added that grade there. While they haven't pressed escape, then I want you to, I could say here, press escape when finished, when all grades are entered, right? Boom. Now let's go back here, see what else we're missing. Add this grade to the running total, got it. Add 1 to the grade counter, got it. Prompt the user to enter the next grade, got it. Input the next grade, possibly the sentinel, got it. If the counter is not equal to 0, so let's make an if statement. If counter is not equal to 0, oh, that white space is looking weird to me. Set the average of the total divided by the counter. So here we go. Counter. Display the average. and I'll display both the average and the total. How's that? And then we have an else. Brackets, please, please, please write in the brackets. Console.WriteLine. No grades were entered. Wonderful. Let's see if that works. So I have it here. I'm going to press enter. Enter a grade. Now, obviously, if I don't enter a grade here, it'll leave the program. And that's not what I want. So I wonder, actually. Oh, fiddlesticks. Go away. Alright, cool. You. I'm actually going to develop this entire thing, and I don't want to do that, actually. Alright, I can't leave this. Oh, I put that in the wrong spot. It's a do while. And I haven't... Alright, so we'll come back to this. I don't want to write it. I know how to fix it, but I don't want to write it right now until I've gone over a little bit more. So, but we are going to fix this and make it work. Terminate the top-down stepwise refinement process when you've specified the pseudocode algorithm in sufficient detail for you to convert the pseudocode to C#. Normally, implementing the C# app is then straightforward. Some experienced programs write apps without ever using app development tools like pseudocode. They feel that their ultimate goal is to solve the problem on a computer, and that writing pseudocode merely delays the production of final outputs. Although this method may work for a simple and familiar problem, it can lead to serious errors, and that is very true. Normally, you want to write out, especially the large, complex programs, you want to write it out. You want to test it first. You just don't want to go out there and write it and go, oh, well, there it is. That's always a recipe for disaster. So, we're going to implement the algorithm for Sentinel controller partition. Now it's going to show us how to do it. I really wanted to do it myself, but I want to make sure that I'm writing it exactly the way that they write it, because there's actually many different ways you can do this. And so we already have all of that. And while grade is not equal... Ah, that's what they did. But then they must have had... Hold on a second. Interesting. Oh, I see. And that satisfies both sides. Okay, so what they did was they're checking to see if the grade is equal to -1. I wouldn't have done that, but that works. And then in your while loop, what it's doing is it's saying, okay, while the grade is not equal to -1, do some stuffs. If the user enters -1 here, guess what's going to happen? It's going to go back and it's going to not work. So technically you could have said quit, but no, you can't, because then it wouldn't be a number. It wouldn't be a value that the grade would take. This is an interesting conundrum. I would like to spend more time trying to actually find a better solution to it. But for now, I guess -1 works. And then, of course, the grade counter would execute and all the rest of it. So I'm not going to write any of that, because I didn't write it the way... Well, I didn't write that. And I don't want to do -1. It's not best practice. There's a better way. As a matter of fact, to be more concise, I would not have, in this situation, used a while loop. Or maybe, it depends. I would have probably tried to use something else. In a Sentinel-controlled loop, the prompts requesting data entry should explicitly remind the user of the Sentinel value. Meaning, if the user needs to know that -1 is what would remove them from that while loop, you need to continue to remind them of that. As a matter of fact, you know what? I will write it, just so that you guys get a better idea of what this is doing. So, grade, actually, they have a grade variable. grade. There's also a better way to write these, but theoretically speaking, what you could have done, or what I could have done, because variables are obvious, right? So if you don't want to write int 5,000 times and you don't want a bunch of lines of variables out there, you can do this. And what that essentially does is it takes all your variables and puts them in the same. It is understood that all these variables are integers, so you don't have to write int over and over again. You can separate them by a comma and you can write them on the same line. Also good for readability. So in this case, grade is not equal to -1. -1, please. And then here, I wouldn't say grade total is that. I would actually say grade equals, I didn't mean to do that. So instead of doing that, I would say, and this is why I didn't want to do it, because it changes the way the code, I wrote the code, which I don't need to say int grade because I've already instantiated it or assigned it. That's what I wanted to do. So int grade total equals 0, grade average equals 0, counter equals 0, grade equals 0. And then grade equals whatever the user entered. While grade is not -1, I want you to run some stuff. And in this case, what they said was when they entered the grade, they also said so. Please enter the grade. I probably should copy this up here. There. And that's pretty much it. The average, though, would not be an integer, so I can actually take this out. Remember they talked about decimals, right? So let's get the actual double. Let's get the actual value that way. And then grade average, grade total. Okay, that all looks good. That all looks good. If grade counter, yeah, counter, got that. Else, no grades rendered. Okay, so let's run it this time, and let's see what we get. So enter -1 to exit, -1. No grades rendered. Boom, it worked. Now, obviously, I don't like the -1. I would have liked to use something else. But in this case, -1 really does mean that that I'm done. I'm finished. So let's say that I wanted to run this again, and I entered some values. Let's just test to see if values would work. 60, 84, 90, 58, and then I said -1. Grade average is 50. That's not correct. And that's not 10 grades. I should say the total of all... Oh, wonder bar. That's still not right. I wonder why I did that. And then I want counter. And in this case, 1, 0. Let's run it again. Alright. So what did I do? I changed it. I added a string, or I added a value to my string builder, and I wanted to see why I didn't get the decimal. I was supposed to get a decimal there. So 50, 82, 84. We'll just do some numbers that may give me a decimal. Alright, and then -1. Ah, there we go. Decimal. So the grade point average is 64.5. I wonder if that's because I said that grade total and counter were both, and I had to convert it to a double after the fact, as I did there. This is converting the value that is returned by grade total and counter to a double. And then because grade average is a double, it accepts it as a decimal. So, but this is the way it works. Bus. All right, cool. Yep. Omitting the braces that delimit a block can lead to logic errors, such as infinite loops. Remember, curly braces are very important. Please do not just not use them. Please use them at any given, where they are needed. To prevent this problem, some programmers enclose the body of every control statement in braces, even if the body contains only a single statement. So, to perform a floating point calculation with integer values, we temporarily treat these values as floating point numbers, putting them in brackets, as I did here with double. Okay, so look, integer, grade, total, counter, and grade are all integers. These are all integers because they're all on the same line with the integer data type. I could have written these on their own lines. It would have been integers as well, but they're all integers. If I scroll over grade total, look, it says int grade total. If I scroll over counter, it says int counter. But if you divide an integer with an integer, you're going to get a whole number. You're not going to get decimals back. That's why I said I was getting a logic error. I was like, well, 201 divided by whatever that number is not 50. It's 50 dot something, right? So in order to get it as a decimal, I have to temporarily assign a double or a decimal type data type to these two numbers or these two variables. And to do that, I added a unary cast operator, in this case double, to both of them. I could have done float as well. Float would have worked. But you'll see, okay, cool, float works. If I said int, it's redundant, I don't need it, but all right, yeah, that still works. So double is the most efficient way to do it in this case. So what the unary cast operator such as double performs is called an explicit conversion. It doesn't convert the variable. The variable is still an integer, but the value within the variable, or the value that will be created from dividing those two variables, must be a double when it comes out. C# performs an operation called promotion or implicit conversion on select operands for use in the expression. That's a lot of really big words. Just understand that putting double in parentheses or in parentheses next to the equation, as we did here, double grade total divided by counter, what it does is what this will become, or the quotient will be a double when it goes into grade average. If I didn't do this and I tried to run this program, so let's say I said 55, 87, 92. All right, 55, 87, 92. Remember those numbers. And then I said -1. I got 59. Let's try that again with the double there and see what we got. So same numbers, 55, 87, 92. I actually got the decimals. So with that double there, it treated whatever grade total divided by counter, the quotient, it treated it as a double and it assigned that to grade average. So remember, if you want to temporarily assign or assign explicitly the result of two numbers that are not a double or integer, you just use this and it will do it. So a cast operator can be used to convert between simple numeric types. So integer is whole numbers. It is always whole numbers. It doesn't round up or down. Doubles are decimals. Now, doubles can contain integers, but integers cannot contain decimals or doubles. And decimal numbers can be displayed as a float data type, double data type, and a decimal data type. So casting the wrong type may cause compilation or runtime errors. So a cast operator is formed by placing parentheses around the name of the type. This operator is a unary operator. We just talked about that. Cast operators associate from right to left and have the same precedence as other unary operators such as unary plus and unary minus. This precedence is one level higher than that of a multiplicative operators, multiply, division, and modulus. Remember what that does? It gives you the remainder of. So if I put a unary operator like this in my algorithm, it has precedence over that. PEMDAS. PEMDAS, PEMDAS, PEMDAS. Please excuse my dear Aunt Sally. It's still prevalent here in computer science as well. PEMDAS. So it's parentheses, exponents, multiplication, division, addition, subtraction. It hasn't gone away. And for those of you who just hate math, hate is a strong word, by the way, but equally so, if you hate something, you can also learn to love it. Math is wonderful as long as you have the right individuals giving you the knowledge. And I would hope that I am the right individual. In this app, the 3 grades entered during the sample execution of class gradebook test totaled 263, which yields the average 87.66666666. Repeating. The format item rounds the average to the 100th position, and the average is displayed as 87.67. And that's if we wanted to format it, as they do in figure 5.10. So here's your gradebook test main. All we're doing is calling the gradebook class into the myGradebook variable that has the gradebook data type associated with it. And then we're asking myGradebook to execute a few functions that it contains. In this case, 87.67 is the answer that they're getting here. Now, I would tell you that we're not formatting our output, so we're not going to get 87.67, but if we did, we could. I don't remember. I could say math.round, actually. I just don't remember what. Give me a second. And I think I have to call that, by the way. So math.round, C#. And then I just want to see an example. Sorry. Here's an example. Okay, we can do that. We can do that. Well, honestly, where's the... Okay, I think I see it. This is it right here. All right, there it is. This is it right here. Okay, so let's go back to our code and let's round it. Since that's what they are doing, let us also do that. I want grade average, and I want math.round grade average by 2 decimal places. So now if I ran this and entered the same numbers they entered, so they entered, and I'll flip back over to that one so you guys can actually see it. So 96, 88, 79, minus 1. 96, 88, 79. Weird. What? How did I get that? It should have... Oh. I understand. Okay. It didn't take 96 because this is outside of... I don't want this outside, actually. Forgive me. So so to show you what I'm doing, I don't want this outside of the while loop, so I'm getting rid of it. I actually don't need it outside of the while loop, to be quite frank with you. So enter, and then if I entered the 96, 88, 79, and then -1, I still got 262 because it was 4 grades. I thought I was starting the counter at 0. Interesting. Why would it do that? Wonderfully, I am debugging, and this is something that I like to show you guys while I work. It's not just sometimes, or in most situations, all developers run through this situation or this issue where they're trying to figure out... Alright, so I guess I need them both. So grade total, this is redundant, but equals grade. Okay. I wasn't adding this grade to the grade total, and then I was actually putting a new grade in there, so I'm going to try this and see if this works. I don't like this. It seems like... I'm going to show you what I'm doing. So at first I just had this, right? And this is the way it was running. It would ask the user to enter a grade, and it said that -1 was the way that it would exit, and then take the grade. But I wasn't assigning the grade to the grade total, and then I was asking for the grade again. So what I need to do actually is put the grade in the grade total. It's painful because that's kind of redundant. I wish I can double assign. Can I double assign? Can I in the name of efficiency, yeah? Ha! Maybe that'll work. No, it won't. Double assignment. Alright. Wow. Plus equals grade. I know there's a way to double assign, but I'm not going to do it right now. So let's do that. And let's run it. See what happens. So, 96, 88, 79. No more logic errors. I did get a logic error, but that's not a logic error based on... Did I write the wrong number? Oh, -1. -1 is decrementing by 1, and I'm getting... You see that? 263, -1 is taking the -1 value and adding it. That's not good. So, actually, what I need to do is say... not while running. Yeah. So let's ignore the -1. So if grade, what am I doing? If grade is not equal to -1 and true to the magic of Visual Studio, it indents it for me. So if the grade is not -1, don't do this. Wonderful. Well, no, I needed to do that. But don't do the other thing. Wonderful. Okay, let's try it now. So, let's flip it back over. 96, 88, 79, -1. Bam! Got it. B-A-M. Bam. All right. So, what did I do? And I was debugging to find out why I was getting these errors. So essentially what I did was I added grade total compound assignment, which is grade total equals grade total plus grade, to the grade total. And then in the while loop, I did some other things. I did it again. I wanted to ask the user for what they wanted. And then I said, if the grade is not equal to -1, then I want you to do this. I want you to add the grade to the grade total. And then count or increment the counter by 1. And that's what I did. So, it worked. Wonderful. So let's continue. Consider the following problem statement. A college offers a course that prepares students for the state licensing exam for real estate brokers. Last year, 10 of the students who completed this course took the exam. The college wants to know how well its students did on the exam. You've been asked to write an app to summarize the results. You've been given a list of these 10 students. Next to each name is written a 1 if the student passed the exam and a 2 if the student failed. Yeah, this looks like a Boolean expression, does it not? 1 and 2. I know that it's not a computational Boolean expression, but it is a Boolean expression nonetheless. It's a true or a false. That's what Boolean expressions are. That's what they actually do. So I think it's 1 if it's true. Yes. 1 if they passed. 2 if it failed. Your app should analyze the results of the exam as follows. Input each test result, 1 and or a 2. Display the message enter result on the screen each time the app requests another result. Count the number of test results of each type. Display a summary of the test results indicating the number of students who passed and the number who failed. If more than 8 students passed the exam, display the message bonus to the instructor. So after reading the problem statement, we make the following observations. The app must process test results for 10 students. A counter-controlled loop can be used because the number of test results is known in advance. Each test result has a numeric value, either 1 or a 2. Each time the app reads the result, the app must determine whether the number is a 1 or a 2. We test for a 1 in our algorithm. If the number is not a 1, we assume that it's a 2. So, in this case, we can use an if-else. Because we really don't care what the second value is, because as long as it's not a 1, it's not a 1. If it's a 2, then it's not a 1. If it's a 1, then it's not a 2. You see how that works? So if it's a 1, great. If it's not, well, everything else is going to be false. 2 counters are used to keep track of the exam results. 1 to count the number of students who passed the exam, and 1 to count the number of students who failed the exam. After the app has processed all the results, it must determine whether there are more than 8 students that passed the exam. Now, we could write this. I'm not going to write it. I think they've already written it for us, to be honest. Proceed with top-down stepwise refinement. Analyze the exam results and decide whether the instructor should receive a bonus. So our first refinement is initialize the variables, as always is phase number 1 of the top-down stepwise refinement. Input the 10 exam results and count the passes and failures. display the summary of the exam results. So what we did was we took this one statement and broke it into 3 phases. Initialize the variables, receive the data, compute the data, and see whether or not the instructor should receive a bonus. So we're going to initialize the variables. What variables do we need? Well, we need variables for the counter, we need variables for passes, and we need variables for failures. The next pseudocode statement is more complex. So input the 10 exam results and count the passes and failures. So in that case, we have a while statement that will more than likely not need a sentinel of any kind, and the student counter is less than or equal to 10. Prompt the user to enter the next exam result, input the next exam result. If the student passed, add 1 or increment the passes variable by 1. Else, increment the failure variable by 1. Add 1 to the student counter. Display, and this is the last phase, display a summary of the exam results and decide whether the instructor should receive a bonus. So display the number of passes, console.writeLine number of passes, display the number of failures, console.writeLine the number of failures. If more than 8 students passed, display bonus to instructor. So, in this case, we have another program called analysis test, and that shows us how this is done. It's not that much different from what we've already done with determining class average. It's just not as many of the moving parts that we have, because at this point we don't need to do a equation on 2 variables. We just need to know how many passes and how many fails there are. So here's the pseudocode. We've already talked about it, and here's the actual code. So the variable for passes, the variable for failures, all initialized to 0, by the way. The variable for student counter initialized to 1, and the int result, which is the exam result of the user. Now, you don't necessarily have to do that. You could have put the result in the while loop, because we really don't care about the result outside of it. We just care about it within the scope of the while loop. Once the while loop finishes, the int result is irrelevant to us, because it'll accept 1 exam result per user, so to us it doesn't really matter. It matters here. So I would have said int result in the while loop, but that's neither here nor there. So enter the result, pass or fail, and then I want you to convert that to an integer. You don't have to, but I would only convert the value that I get back from read line to an integer if I need to do a mathematical computation on it. If I don't, then I really don't. It really doesn't matter. So if the result equals 1, I want you to increment passes by 1. Now, that obviously we've talked about this already, but there's a better way to do that, right? You can increment using passes plus plus. Else, increment failures by 1, failures plus plus. And then increment the student counter by 1, student counter plus plus. And then I want you to display, after this while loop is complete, I want you to display all the failures and all the passes. So you can see these are the variables, and that 1 is where the failures go, and the 0 is where the passes will go. So, as we continue, if the passes is greater than 8, bonus the instructor will display. And there you go. Bonuses to instructor. I'm not going to write it. It's a very simple code. If you want to write it, you can. The code files are there. If you want to just pause, go back a couple of seconds, pause, and write it yourself, so you can kind of see that it works. You can. And you can see that if there's less than 8, there is no bonus to instructor here. Initializing local variables when they're declared helps you avoid compilation errors that might arise from attempts to use uninitialized data. While C# does not require that local variable initializations be incorporated into declarations, it does require that local variables be initialized before their values are used in an expression. So, C# provides several compound assignment operators, and we've talked about this. I'm not going to say it again, or I guess I could say it again, but I'd be insulting your intelligence. We've talked about this. So there's plus equals, minus equals, multiplies equals, divides equals. So 513 shows the arithmetic compound assignment operator and sample expressions using the operators and explanations of what the operators actually do. And here we go. Save this slide or look it up on Google, but as I've stated, these are all to include the modulus. I didn't even realize that modulus could do it as well, but modulus is also a thing. So, and modulus will give you remainder of. So, in this case, if I actually get rid of my gibberish, and you can see assume g equals 12. So if g equals 12, then g equals 12 divided by 9. Remainder of that is 3. But these are all the compound assignment operators, and they're worth remembering for sure. So C# provides operators for adding or subtracting 1 from a numeric variable, and we've already talked about this as well, plus, plus, minus, minus, and they work just fine. I use it in the code to do counter, or to show you how counter works here. Minus, minus also works as well. And here we go. You can do it before, which is a prefix increment. You can do it after. And of course, they have their merits. So increments by 1 and uses a new value of the expression in which a resides. Increments by 1 but uses the original value of a in the expression. So this increments by 1 and then uses a. This increments by 1 but still uses what a was before it was incremented. The same goes here and there for minus. Unlike binary operators, the unary increment and decrement operators should, by convention, be placed next to their operands with no intervening spaces. Meaning, plus plus is not plus space plus is plus plus. Minus minus is not minus space minus, it's minus minus. So here we go. C equals 5. So C++ increment C and display 5. This means to, or display C and then increment it. This is increment it, then display C. So passes equals passes plus 1, failures equals failures plus 1, and we've talked about that. I brought it up already, but passes plus equals 1, failures plus equals 1, student counter plus equals 1, and this is ignorant. I wouldn't even done that because 1 is the same as plus plus, right? So I could say passes plus plus equals, it's the same thing. Saying 1 is redundant. Using this compound operator for 1 is the same as saying student plus plus. So just say plus plus. This is even more precise with prefix increment operators, so, or postfix. And I actually just said that. Attempting to use the increment or decrement operator on an expression other than one to which a value can be assigned is a syntax error. For instance, writing plus plus is a syntax error because x plus 1 is not an expression to a value to which a value can be assigned. So we're going to show precedence and associativity of the operators we've introduced to this point. So you have new, you have the postfix plus plus, and the postfix minus minus from highest precedence left to right. Dot is first, new is second, and so on and so forth. This pretty much is kind of like PEMDAS, and it goes over what is preferred. This is good, right? This is good to know. However, what I will tell you is that for mathematical expressions, if you are confused or you don't understand why or how PEMDAS works or you don't remember, just remember parentheses is first. So if you want to do a calculation on something first, just put it in parentheses. It's that simple. And then the associativity of, true and false, and the associativity of assignment. This is a very important table, by the way. So if you feel that you need to print it, save it, whatever the case may be, please do so. The table in Appendix B, simple types in C#, requires all variables. Well, okay. All variables are required to have a data type. And all data types, it's very simple to remember the easy data types, right? Integer, string, date time. There's a lot of data types. There's tons and tons and tons and tons and tons. So understanding or remembering all of them might not necessarily be easy. So don't wrap your mind too tightly around this. Just understand that there's a lot of simple data types out there that can be used within the core context of C#, and that all variables in C# require a data type. Instance variables of type bool are given the value false by default. So if you have a Boolean expression, or you say bool, like for instance, if I said, let's go back to the program. If I instantiated or if I initialized a variable, so bool x, I didn't assign anything to that Boolean expression. So, or I didn't assign anything to that Boolean variable x. In this case, x is false. If I asked it to display it, so I said, I don't really care about the rest of this, and I just want you to console.writeLine x, and then, oops, readline, and I ran this, is it not going to work? Use an assigned, oh, I didn't assign anything to it. Okay. I know a way around that. Oh, it's not a way around it. Okay. Alright, so it's treating it like it's a... Alright, whatever. Will that work? The name writeLine does not exist. Yes, it does. Alright. Interesting. Very interesting. Well then, okay. But either way, I was trying to prove to you that the default value of... Well, hold on a second. What if I said bool x? Object not referenced when it's an object. Property name, predicate, program x. Well, I'll be. What if I said static bool x? I'm trying to get gaming right now. I'm gaming the system. I want it to give me the default without actually assigning a default. Bool return. And then I said x. Ha! Ah, it didn't work. I'm trying to game the system. It's not working. Invalid expression. But why? Bool x. How about that? X. And then this needs something to overload it with. Fiddlesticks. I don't think there's any way around this. But either way, I can't prove it to you right now. I don't know a way around this conundrum. Yes, yes, yes. I'm aware. Violation fixed. But there's a Boolean here, so. What if I bool x? Can I do that? No. It needs a local assignment. It won't let me do that. Alright, well. C'est la vie. I can't prove it to you right now. I will figure out a way to prove that to you. But the Boolean expression of flip back over. Instance variables of type bool are always given the value false by default. I can't prove it. I wanted to show you that, but it won't let me. And that's it. So, this was a long one, and it was a good one. There's a lot of good information in there. Like I said before, if you're having issues or you're having a hard time, just reach out and let me know, and I will help you any way that I can. Otherwise, you guys have a good one. Ciao.